Hi, hello friends. Welcome to my YouTube channel. Now, in this session, we will continue our discussion on DC transient circuits. In the previous session, we discussed the first order source free circuits. Now, we are going to discuss the step response or forced response of first order circuits. So, let's continue our discussion here. So, I will take a voltage source V in series with a resistance and capacitance like this, and at t is equal to 0 time period I am closing the switch here. So resistance is here and capacitance is here. Now by closing the switch I can apply loop equations, so mesh analysis, sorry. Okay, mesh analysis. Now I of t in this loop, it is reading in clockwise direction, flowing in clockwise direction. So by KVL I can write here, so minus V, so plus minus here, minus V plus I into I of t into R plus, so V is equal to 0. So we know what is V. So I is equal to C into dV by dt, already we know about it. So from this we can write 1 by C integration of V into, I into dt here. So that is what written here. Now I want to eliminate this integration here. So that's why we are doing differentiating on the both the sides. When you do differentiating, so this equation is going to be, so minus v is here, so I am going to send this c, so v become here. So when you differentiate, dv by dt is going to be 0, that is 0, and r into I of t into dt plus the integration and differentiation gets cancelled, so that 1 by c into I of t is equal to 0. This is the equation I got. So this is the first order differential equations. So already in my previous session we discussed how to solve this kind of differential equations. We will do integration on the both the sides by taking the limits from 0 to t. Okay, so that we will get I of t is equal to a into e power minus t by rc. So what is a here? A is nothing but it is integration constant. Okay, so it is integration constant here. Now how we are going to find here? So very important concept here. So capacitor is initially uncharged, that means Q is going to be 0. So as we know from the basics, Q is equal to C into V. Once Q is 0 means C is a physical parameter which cannot be 0, and voltage is going to be 0. So once voltage means we can treat that the capacitor act as a short circuit. Okay, so capacitor doesn't allow sudden change in voltage, right? So earlier it was capacitor, voltage across the capacitor is 0. Now it will try to oppose it. That means it will remain 0 only after few seconds of time. That depends upon the time constant of the capacitor. So at t is equal to 0, the capacitor behaves as a short circuit. So I of 0 is nothing but voltage source is there, resistance is there. So what is I of t? I of t is nothing but V by R. So t is nothing but 0 here. So similarly, in order to get this I of 0, so I of 0 is nothing but Vs by R. Okay, so from the previous formula we written here, that is I of 0 is equal to a into e power 0. So e power 0 is nothing but 1. So I of 0 is nothing but here a. So which is nothing but V by R. Now, so total equation I of t is equal to V by R into e power minus t by tau. So initially capacitor acts as a short circuit so that the current is having maximum value. But as it's charging, it is going to behave as a open circuit finally here. So current 0 means we studied it is act as a open circuit. Starting it behaves as a short circuit. Okay. So now what is the voltage across resistor? So voltage across the resistor is nothing but I of t into R. I of t only we derive from here. So that is V by R into R is nothing but V into e power minus t by tau. We got it. Next, voltage across the capacitor. So voltage across the capacitor initially is going to be 0 and final is going to be a steady state value. So we'll see that. So Vc is equal to 1 by c integration 0 to t. I of t into dt is nothing but, so if we do integration here, so tau constant we will become here. So V by Rc into e power minus t by tau minus of 1 by 1 by tau means tau. So here we will define tau is nothing but Rc, time constant. Okay. So if you solve this equation by taking the time period t to 0, integration here 0 to t, you will get the final equation as Vc is equal to V of 1 minus e power minus t by tau. So we can check. Suppose at t is equal to 0, we assumed that t is equal to 0, capacitor acts as a short circuit. So see, at t is equal to 0, e power 0 is nothing but 1. So 1 minus 1 is nothing but 0. So voltage across the capacitor is 0. So this equation satisfies our initial conditions. Okay. Next one. So now we can define a general equation that is V of t is equal to Vc of 0 plus minus V of Vc of infinity into e power minus t by tau, where tau is equal to how much it is Rc plus Vc of infinity. So this is a general equation. We'll use it in step response or source free response. So this is an important equation. What is V of 0 plus? V of 0 plus is nothing but voltage across the capacitor before switch operation, and assuming that it is in steady state. So this is steady state value. Similarly, V of infinity voltage across the capacitor after switch operation and steady state. So this one also steady state value. Okay, so these two are the steady state values here. So here also steady state value. Okay, now what is the current flowing through the capacitor? So just now we have seen IC of t is nothing but C into dV of t by dt. So C into d by dt of V into 1 minus e power minus t by tau. So we got this is the equation, and we seen in my previous slide that the current decaying like this. That means the capacitor is getting charged and finally become open circuit here. So initially it is short circuit. That means this case is valid when Q initially no charge is present. So Q is 0 means this case is valid. Okay, now that is power across capacitor. So PC of t is nothing but Vc of t into Ic of t. So from this V square by R into 1 minus e power minus t by tau minus e power minus 2t by tau. So if we draw the power curve with respect to time, it is like this. Okay, so this is the power stored by or energy stored by capacitor. Okay, it is maximum at this point. At t is equal to 0, Pc is equal to 0. So as you can 0, here 0. So t is equal to infinity also, P is equal to 0. You can substitute t value and as a 0 and infinity, you will get the same answer. Okay, so I R of t, the current flowing through the resistor, is nothing but V by R into e power minus t by tau, which is already seen. Now, I want to know what is the voltage across resistance. Okay, so that these two equations we can find what is the power across, resistor. Okay, so V is here, VR, VC. So applying KVL in this loop, assuming that I of t, so minus V plus VR plus VC is equal to 0. So VR of t is equal to step voltage minus capacitor voltage. So from this we can get this equation. Okay, so these two equations are there. So P R of t is nothing but VR of t into IR of t is nothing but Vs square by R into e power minus 2t by tau. So Vs square by R into e power minus 2t by tau. What is the meaning of significance of this equation? That means the power dissipation. So power dissipation in resistor is 2 times faster than charging of capacitor. So it will dissipate the power so fast compared to capacitor. That is the conclusion here. Now energy stored in the energy across resistor. So energy across resistor is nothing but ER of t is nothing but integration 0 to infinity PR of t into dt is nothing but we will get it as half CV square. So this is the half CV square. Now what is efficiency? So in case of RC circuit, we close the switch like this. It is like this. So V RC. So after energy across resistor, how much energy dissipated means it is going to be half CV square only. The efficiency is nothing but output power by input power. So we are going to check the here output power across capacitor. So this is total power. Okay, so input power is the energy is given to the resistor and capacitor. Output is nothing but only for capacitor. So output power by input port, output energy by input energy. What is the output energy across the capacitor? So EC I am taking. Total input power. So input power is nothing but sum of these two. So energy across resistor plus energy across capacitor. So this will give efficiency of 50%. So similar kind of efficiency we found in maximum power transfer theorem. So maximum power transfer theorem efficiency we are getting maximum of 50%. So similarly here also we are getting in RC circuit maximum efficiency of 50%. Okay. So next we will see a simple problem based on RC circuits. So here the first thing is, here the circuit is given voltage 20 microfarads, 50 and 200 ohms here. I of t, switch is here t is equal to 0, 0.1 amperes is the current source. What I need to find is V of 0 plus. What is the voltage across capacitor? So first condition in any circuit analysis, DC transients, first take RT is equal to 0 minus. So once you take 0 minus means how the circuit will behave. The switch is in open position or closed position. So at t is equal to 0, I am closing the switch. That means switch, let's say name it as S. S is open. When you open the switch, okay, so open the switch. If you redraw the equivalent circuit, and capacitor is not initially charged. So capacitor is not initially charged, and assume that t equal to 0 minus the capacitor attains a steady state condition. So steady state condition. So steady state condition means capacitor act as a open circuit. So open circuit here. So V plus minus 50, and here we are having 200. Capacitor is open, which is open circuited. The current will flow like this. So here this part is open circuited means no current is entered into this circuit. So what is the V? So V of 0 minus is nothing but 200 into, so 0.1, so which is nothing but 20 volts. So V of 0 minus, as we know that the capacitor won't allow sudden change in voltage, so V of 0 plus is also 20 volts only. So the first option here we got it as 20 volts. Similarly, I of 0 plus. So after closing the switch, so once we close the switch here like this, so at t is equal to 0, we are closing the switch. The current flowing through this circuit only. The current is going to be flowing through this. So if this current is flowing through like this, so this switch closed position will make this resistor short circuit. So once it's short circuit means this one. Okay, so current always try to flow in this path. So here it is going to be 0 amps only. Okay, so I of 0 plus is nothing but 0 amps. So 0 amps is the answer. Next one, we need to find V of 2 milliseconds. So V of 2 milliseconds. So generally the formula that we are going to use here is, that is, so V of t is equal to V of 0 plus minus V of infinity into e power minus t by RC plus V of infinity. So what is V of 0 plus? So V of 0 plus is nothing but 20. What about V of infinity? So once we close the switch here, so once the switch is closed here, what the entire current is flowing through like this only. So this RC becomes, so the current here is going to be 0. And what about the capacitor here? So capacitor is going to be source free circuit. So source free circuit means V of infinity is going to be 0 volts. Okay, so why? Because the whatever the energy stored by the capacitor is going to be delivered through this path like this. So after t is equal to infinity, it is going to be open circuited. So open circuited means no current flow here. V is equal to 0. Now, so V of 2 milliseconds I required. So what is V of 0 plus? 20. V of infinity 0 into e power minus t by, what is R value? R value. So looking from the inductor side, capacitor side, we should check. So if you see from this side, if you're looking from this side here, so this capacitor, okay, the only thing is 50 ohms resistance is available. So 50 into, so capacitance value here it is 20 microfarads. So 20 into 10 power minus 6. Okay, so it is nothing but 20 into e power minus t by 10 power minus 3. So when t is equal to 2 seconds, 2 means 2 into 10 power minus 3 seconds. So v of 2 milliseconds is equal to 20 into e power minus 2 into 10 power minus 3 divided by 10 power minus 3. So it is going to be 20 into e power minus 2, which is nothing but 2.71 volts here. Okay, right. So next topic is series RL circuit. So step response of first order circuits here. So series circuit. So RL series circuit here. So now we'll go for the same analogy. So voltage source is here and we are taking series RL here. So current assumed to be same. I of t is equal to current flowing in the circuit here. So we are applying KVL here. So by writing KVL, so minus V plus R into I of t plus L into di by dt is nothing but voltage across inductor here and voltage across resistor, voltage source. So again, so here by equating these equations, that means, so if I send this L outside, so di of dt by dt plus R by L into I of t is equal to V by L. So this above this equation, so this equation, let me give name one. The above equation is a nonlinear homogeneous differential equations. Nonlinear homogeneous differential equations where the solution is given by I of t is equal to, this is sum of transient response plus steady state response that we discussed in the previous lecture. So IC is nothing but complementary function. So complementary function, or it is also called as exponentially decaying function, which will give the transient response. So transient response it will give. What about this V by L? So V by L will give this steady state response. Okay, so IP is nothing but particular solution, or it will give steady state response. That means this equation will have two parts, complementary function plus particular integral, right? So complementary function, so complementary function gives the source free response, is we see. So exponential terms will come here. So and during steady state, inductor act as short circuit. When the inductor act as short circuit, so voltage source is here, switch is closed, resistance only available, inductance is short circuited. So what is the I of infinity is nothing but V is here, R is here. So I is equal to infinity is equal to V by R. Now, so I of t is nothing but it's a combination of complementary function plus particular integral. So complementary function is a into e power minus t by tau that we seen in our previous sessions. Now it is equal to V by R plus a into e power minus t by tau. In order to find a, so in order to find a, we are taking initial conditions as we did in the previous case. So we got a is minus V by R. So a is equal to minus V by R here. So finally, what you can write? So I of t. So I of t is nothing but the combination of two things we did earlier. Now we substitute a value here. So if we get a value, V by R into 1 minus e power minus t by tau. So in general, how you written in the previous voltage equation in case of RC circuits. So similarly, you are writing general equation for current in inductor. So I of t is equal to I of 0 plus minus I of infinity into e power minus t by tau. So here tau is equal to L by R plus I of infinity. Okay, so here I of 0 plus is now the current flowing through the inductor before operation in steady state condition. I of t is nothing but current to the inductor after operation in steady state. So both I of 0 plus and I of infinity both are steady state conditions only. Voltage across inductor VL is equal to L into di by dt. Inductor will never allow sudden changes in current, but it will allow in voltage. That's why we will see here. L into di by dt, L into d by dt of V by R into 1 minus e power minus t by tau. If you differentiate this equation, you will get exponential decaying function. That means inductor voltage is maximum first, that is it acts as a open circuit. Finally, when it reaches to steady state, it will act as a short circuit. So V of t here. So inductor, when during steady state, it acts as a short circuit. During initial stage, it is act as a open circuit. Now, so power across inductor. So VL of t, IL of t. So just we derive these two formulas. From this, we'll get this equation. Again, we can observe the thing here is power decaying is 2 times faster than charging of the capacitor. Sorry, inductor. EL of t is nothing but integration 0 to infinity PL of t into dt. So from this condition, we will get this energy across the inductor is half L into V by R square here. So similarly, we can get R value, IR of t is equal to V by R into 1 minus e power minus t by tau. So units are amps. Okay, so by writing the KVL equation in the loop, so switch is closed here, resistor, inductor, so V, VR, VC. So minus V plus VR plus VC is equal to 0. So we got VR value as this equation. Now, power across resistor. So VR of t is equal to VR into IR is nothing but VR square, V square by R into 1 minus e power minus t by tau whole square watts. So ER of t. So ER of t is equal to integration from 0 to infinity PR of t into dt. So how we got this is when the voltage source is there, the switch is closed. After closing the switch, the resistance A and inductor act as a short circuit. That means at t is equal to infinity, the voltage source is delivering energy to the resistor and resistor is dissipating its energy in the form of heat. That means until unless source is there, it is going to dissipate only. So that is the meaning of this. So infinite energy, it is going to be dissipate. That's the meaning of this. Efficiency is nothing but, so voltage, as we see in case of capacitance, also same thing. So resistor and inductor here. So what is the energy dissipation across inductor is nothing but output power. So total is output power of inductor plus resistor. So EL by EL plus ER. So this is ER is going to be infinity. So this is infinity means 0. That means efficiency of RL circuit is 0%. So very, very important for competitive exams. Okay, next we will discuss one problem which is important problem here. Now find the expression for I of t greater than 0 when S1 is closed and S2 is at t is equal to 4 seconds. Find the value of current when t is equal to 5 seconds. So this is the question they asked. Okay, now so first at any circuit we will go for at t is equal to 0 minus. So at t is equal to 0 minus means here there are two switches. Let me say S1, S2. So both are open. So S1, S2 open. So S1, S2 open means there is no current flowing through the inductor. And we assume that at t is equal to 0 minus steady state. So inductor act as short circuit. When inductor act as a short circuit means if like as a short circuit like this, so short circuit means no current will flow because there is only one path. This is the path to flow the current and this is the path to flow the current. Both are open means I of 0 minus is nothing but 0. So inductor will never allow sudden change in current means I of 0 plus also 0 only. So this is the first condition. Next, now next thing we will decide and we will go for is first S1 is going to be on and S2 is in off state. That means the time interval is 0 less than t less than 4. So maximum value is 4 seconds. So just before operating the second switch, what is the condition? What is the current flowing through the inductor? So for this, we will take the formula I of t is equal to I of 0 plus minus I of infinity into e power minus t by tau plus I of infinity. So I of 0 plus already we know. What is I of 0 plus is nothing but, so here 0 amps. So 0 amps. And I would like to find I of infinity. So how will you find I of infinity? So I of infinity means it is in the range of 4 seconds only. Okay, so now inductor act as a short circuit here. So it's nothing but, so 40 volts connected in series with 4 and switch is closed here. So this switch is open, so I won't draw it. Again here having 6 ohms, inductor act as a short circuit. So this is the current. What is I of infinity? So I of infinity is nothing but, so I of infinity is equal to 40 divided by 4 plus 6 is nothing but 4 amps. So 4 amps I got. Now I want to know what is tau. Why? Because I want to substitute in this equation. So tau is nothing but L by R. What is the L equivalent here? So only one inductor, there is nothing but 5 Henry. Now what about the R value, R equivalent? So when the first switch is closed, we are going to find what is the voltage across here. When you are looking from here, what is the R value? So R value, in order to find R value, we will make a short circuit across this. So R equivalent is equal to 4 plus 6. Why? Because when you are looking from here, these two are in series. So this is nothing but 10. So tau is nothing but L is how much? 5 divided by 10 is nothing but 1 by 2. Tau we got as 2 value. So substituting in this equation. So this equation will give, so I of t is equal to I of 0 plus is 0 minus I of infinity is nothing but 4 into e power minus t by tau is nothing but 1 by 2 plus I of infinity is equal to 4. So that implies 4 into 1 minus e power minus 2t is the units or amps is the final equation. So this is the equation regarding time period 0 less than t less than 4. Now we will move to the next step. Okay, so that is when S1 and S2, both S1 and S2 closed. So both S1 and S2 closed. When both S1 and S2 are closed, what will be the current? So when these two are closed, what is before closing the switch I of 0 minus what is the current flowing through the inductor? So we just now derive a formula, that is I of t is equal to here 4 into 1 minus e power minus 2t. So I'll write this again. So 4 into 1 minus e power minus 2t here. Okay, so we'll substitute t is equal to 4. Why? Because the inductor will never allow sudden change in current. I will take it as, so I of 4 is nothing but 4 into 1 minus e power minus 2 into 4. E power minus 8 means approximately 0. So we'll get approximately as 4 amps only. So I of 0 minus I got. Now I want to find what is I of infinity. So I of infinity is nothing but when both the switches are going to be closed. So this is equivalent circuit here. So plus or minus 44, and here the second switch is closed. The second switch connection with a series of resistance to voltage source of 10 volts here. Okay, and here resistor is there, inductor act as a short circuit. So current flowing here is I of infinity. So here what we can do is we can go by the source transformation. So source transformation means, so 4 in parallel with 40 in 4 in for 40 volts in series with 4. So we can represent them as a current source. So 40 by 4 means 10. In resistance parallel with the source means it is 4. Similarly, voltage source in series with resistance can be represented as current source in parallel. So 2, the current is 2 amperes. So 10 by 2 means 5. And here we have resistance here. How much it is? 6. So I want I of infinity here. So again we recombine them. That means 4 in parallel with the 2. So we can recombine them at as 4 into 2 by 4 plus 2 is nothing but 8 by 6 is nothing but 4 by 3. And 10 amperes current flowing and 5 amperes current flowing, both are upwards. So we can combine together as a single source of 15. And next one is resistance is 4 by 3, and here 6 ohms. I need to find I of infinity. So by using current division rule, we can go through the equation here. So by current division rule, if we find, we can get it as I of infinity is equal to 15 into opposite resistance 4 by 3 divided by 6 plus 4 by 3. If you solve this, you will get as 2.727 amps. So 2.727 amps here. Okay, that's why we got I of infinity. Now the important thing is to find the time constant. So time constant means here, when you're looking from this part, let me take another color. Okay, we are looking from here, so inductor is here, so it is of 5 Henry. When you're looking from here, so the resistance R 4 is in, so we'll make a short circuit of this voltage sources. You will find the Thevenin's equivalent. So 4 is short circuited voltage source here, 2 here, and here I have 6. So R equivalent is nothing but 4 in parallel with 2 plus 6, so which will give a value of 22 by 3 ohms. So now tau is equal to L by R is nothing but, so L value is 5 divided by 22 by 3, it will give some 0.66, so 1 by tau it will give 1.4667. Okay, so this is the equations we got here. Now finally what we want a t is equal to 5 seconds. So t greater than 4 equation, so t is greater than 4, the condition is I of t is equal to, we'll get it as 2.727 plus 1.723 e power minus 1.4667 into t minus 4 we are taking here. Okay, so t minus 4 is very important. How we got this? Because the delay between the switches 1 and 2 is 4 seconds. So because of that, here we got 4 seconds of time delay. Now, so I of 5 is nothing but, so 2.727 is nothing but I of 0 plus minus I of infinity. So this value. So this value is I of 0 plus minus I of infinity value. So this I of infinity we got it here as 2.727 plus this value plus 1.723, sorry 1.273. So 1.723 into e power minus 1.4667 into 5 minus 4, we will get it as 3.02 amps. Okay, so next, and we'll discuss the parallel RC circuit. So why we are not discussing parallel RC circuit because when you connect RC in parallel here, what is going to happen here is I is equal to C into dV by dt. When you close the switch, a sudden voltage of application of voltage appear across the capacitor. Okay, so that the voltage, because of that voltage, a sudden current I is going to be flow, so which may causes this capacitor as well as other components in the devices. So we won't go for this circuit. Okay, it's not applicable. So next what we'll do is we'll replace the voltage source with current source here. So current source with the switch T is equal to 0, and we are having parallel combination of RC here. Okay, so during steady state capacitor act as open circuit. No, because okay, so this is a circuit here. So what we can do is we can simply source transformation without affecting the terminals of this capacitance. A current source in parallel with the resistance can be represented as a voltage source in series with resistance. So this is what we discussed in our previous classes, and we know the formula. So v of t is equal to v of 0 plus minus v of infinity into e power minus t by tau plus v of infinity. Okay, so if you assume v naught is the initial voltage, then we will get this equation. So v naught infinity is nothing but is into r. Why? Because the current flowing is is into r here. This is nothing but voltage source vs. Okay, next, and why we next take parallel RLC circuit. So in parallel RLC circuit, we are taking voltage source in parallel with R and L. So during steady state condition, inductor act as a short circuit. So inductor act as short circuit means short circuit means it is going to be parallel this voltage source. So voltage source should be never short circuited. That means source is 0. Okay, so to avoid this, we are taking current source here. So current source means T is equal to 0 RL here, right? Now I'm just going for source transformation again. So that means is into R plus, so we are converting current source in parallel with resistance can be converted as voltage source in series with the resistance. So this is what the equivalent circuit. So this is we done in case of series RL circuit, and we know the response I of t is equal to I naught into I naught minus is into e power minus t by tau plus is. The units are amps. where tau is equal to L by R is a time constant. Thank you friends. Thanks for watching my video.